Okay, forces, question 5, part B. So if the roller coaster rolls from point A to point B, a drop of 35 metres, calculate the speed of the roller coaster at point B. Assume that the decrease in potential energy store is equal to the increase in kinetic energy store. That's massively important. Okay, so I've got that's a command as well, assume, and it's worth 6 marks. So I know this is going to be quite a complicated one here. Again, it's 6 marks, so I'm going to prepare for that by giving myself plenty of space. So I'm going to put my split my answer area up into 3 blocks straight away. What do I need to do first of all? Well, first of all, assume that the decrease in potential energy store is equal to the increase in kinetic energy store. So I know that GPE, in this case, is going to be equal to kinetic energy. Okay, and that's going to be my start point. What values do I know? Well, I know if I'm going to calculate GPE and KE, in fact, let me just write down. So I know GPE is KE, so I know this is mgh, and that kinetic energy is a half times m times v squared. I've got to try and find v, so I need to know these other values. So what are the values it's given me? Well, it's given me in the equation above, in the information above question A, it told me that G was equal to 9.8 newtons per kilogram. It told me that the mass of the roller coaster was 600 kilograms. I know that the H now is equal to 35 meters. So I've got GM and H. GM and H, I can work that out. I've got an M there. The only thing that's left is V. So that's all the information I need. The next thing I would do is I'd put the values in. Now I know if you're very good at maths, you might be able to identify straight away. If you divide both sides by M, you cancel the M's out. Okay, I would always urge you just to be careful when at GCSE level in science anyway, be careful manipulating equations too much in their algebra form. I'd always put the numbers in to be safe, because you might lose a mark for substitution if you made a mistake. So let's put the numbers in. So I know that M is equal to 600 times G, which is 9.8, times by 35, which is equal to half times 600 times V squared. Okay, I'm just going to solve it, just get rid of some of the numbers if I can. 600 times, so I'm going to do the calculations on each side. 9.8 times 35 is equal to 205,800. Half times 600 is going to be 300 V squared. Okay, and I'm just going to rearrange and solve. This equation actually is looking much more straightforward than I thought it would, but I've still got loads of space if I need to. I can always move down to that side. So I know that V squared is equal to 205,800 divided by 300, making sure I remember this is V squared, 686, which means V is equal to, I need to square root both sides now, square root of 686, which is equal to 26.2 meters per second. Okay, so that's the equation. You can see the key bit I want to show you with this really is how I've gone about working it out, how I've laid it out to work it out. Be really careful here, 6 marks. If I jump straight to this question here, straight to the answer, because I'm really good at maths, there's a chance I might only get 3 marks maximum for that question. You have to show you're working out now. Most common error, students would submit that answer there. Okay? Be really careful you don't do that. Righty-ho. Hope that was useful. Take care.